Hello and welcome back to Precalculus1, section 1.8 on inverse functions. So, inverse functions behave in mathematics the same way the inverse behaves in the nature. For instance, certain actions can be reversed, inverted, and other actions cannot. See, function, you can think of a function also as action of some kind. You put the sweater on, and then if you take the sweater off over your head, it will be inverted. And to go back to right side up, you can invert the sweater again, and it will be the right side up. You can enter the room, turn the light on, but then you can exit the room and turn the light off, which was the original state before you turn the light on. So technically you can think about do and undo. Function would do something, inverse would undo it. But not every function has an inverse function. Do we have those examples? Of course. Let's make a soup in a regular pot. Recipe calls for half of a teaspoon of salt, and you put half a snow shovel of salt inside. You can't really undo that one, right? Unless you move the soup into the bathtub, right? And then add more water. So, you break a vase, it shatters into huge amount of very tiny pieces. Even if you are to collect them all and spend 3 years of trying to fit them all together like a 3D puzzle, you're still going to see, right, all of the places where the glass was cracked and glued together, and right? There is no undo button for breaking a vase, right? That's it. So certain functions in life can be undone, others cannot be undone. You get sick, you take a medication, it's undone, right? But not all of them, because for some of them we do not have medication to undo the sickness, right? Yes, there is the development, and then when it becomes available, sure. But currently, no. So, when we say y equals f of x, we mean that from the domain, you take an x value, and you map that x value into a certain y value in the range. What we are learning today is that you can use the f inverse, which is f raised to the minus 1, to undo that calculation. In some cases, not all. So if I say that f of 3 is 19, then f inverse of 19 will be 3, because inverse is supposed to undo the calculation. Remember, light was off, you turn it on, that's the function. Turning it off is the inverse function. Sweater is right side up, you flip it out, it's a wrong side up, you flip it out again, it's a right side up, right? So the idea is that the inverse will change, the function will change, and then inverse can bring it back. As I said, not always, but most of the time. So now, if I say that f of x is x plus 3, what would be the inverse function f inverse? What do you think? To undo a calculation that it's done with the problem above. Close? X minus 3, yes. So now let's check this. Give me an x value. 2. How much is 2 plus 3? 5. Now, how much is f inverse of 5? 5 minus 3, which is 2, which is where we started. Oh yeah, they're inverses. Because this is the property of an inverse. Whatever function calculated, inverse is going to undo it. Now, way to find inverse. Well, what I said before, the diagram here, really helps us out in figuring out what the appropriate formula is. To figure out the... See, you take an x value. I'm going to go red here. You take an x value and you say f of x equals y. And then you say that f inverse of y will give you an x. Because, you see, now, once you are here, y becomes the input to give you the x output, right? So it gets flipped. But when you compare these two, what switched? Do you see how x and y switched spaces? Right? So, to find the inverse, swap x and y and simplify. So let's go with the simplest problem, which was f of x equals x plus 3. This is what we had, because we already know the answer here. So what happens? Well, we create y equals x plus 3. Then the problem says swap x and y. So x equals y plus 3. And then the next line says simplify. So y equals x minus 3, right? When you take this, move it to the other side. And now you can just write it as the inverse. X minus 3. And there's your function. There's your inverse that will undo the function. Let's take a look at this graphically to make sure that you are, in fact, swapping x's for y's. So if I draw these graphs, what do I get? Well, my function is x plus 3, which means y-intercept of 3 and go 45-degree up, 45-degree down, like that, and that's my f of x. Now, I also need to graph x minus 3. And x minus 3 is here. So now, let's pick any point on black line. Any. So say x equals, and then we'll figure out what the y value is. X equals 2. Actually, I was thinking 2. Nice. 2. What is this point here? 2, 5. That means that the point 5, 2 must be on the red line, because red line is inverse and it swaps x for y. Do we have 5, 2? Hell yeah. Right there. There's your 5, 2. Any point you pick on the black line must exist in a reversed order on the red line. Must. Let's pick another point on the black line. X equals -1. This value is -1, 2. 2, -1 must exist on a red line. There it is. 2, -1 must exist on a red line, and it does. Okay, one more, and then we're done with graph. -4 is -4, -1. What's the flip of that? -1, -4. Every point on the black line will have its inverse, which is the coordinates switched on the red line, because the output of the red line is the input of the black line and the opposite. Why are we doing this? Why are we learning this? Because we need to undo calculations in some cases. And that will be done through inverses. Now, there's way more stuff in math that we use it for, but that one is kind of nice introductory idea. Now, it is very important to understand that every function has an inverse, but not every function has an inverse function. We have to understand now, I'll write it in blood, inverse is not the same as inverse function. Now, you will worry much more about this when you get to trig and calculus. But right now, we're learning fundamentals. You see, anything has inverse. Anything. But not every inverse is a function. Now, we all remember, hopefully, lecture number 1, when I talked about a vertical line test. Vertical line test is the test that if it cuts twice through, you pick an x and you draw the vertical line. If it cuts through the line twice, the line is not a function. That was our best method graphically to determine if something is not a function. We used it for a circle to show it's not a function, and so on. ellipse, and a whole bunch of stuff. If you look at the black and the red line separately, they pass the vertical line test. Because every vertical line you draw cuts through black only once, cuts through red only once. So no matter where you draw a vertical line, it's called a vertical line test, and clearly both of these are functions. But that's not true for every black function you can draw and have a red function, right? Which is actually not going to be a function. Look at this. If you draw an x squared, x squared will have a 0, 0, and then these at once, and then 1, 2, 3, 4, and a 4. And you draw the line which has to curve and come out the other side. This is x squared graph. This is this, let's put x squared up here. That's x squared. Is this a function? Yes, it is. It passes the vertical line test. No matter where you draw the vertical line, it will never cut through the black line, through the function. It will never cut more than once. Now consider its inverse. Remember how you find an inverse. For the inverse, you are going to take every point I outlined on the left graph and switch their coordinates and graph the red inverse line on the right graph. So, if you draw the table of values, your function says, let's start here, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. These are the points that are on this graph. Now, we are going to flip these into 4, -2, 1, -1, 0, 0 stays, 1, 1 stays, and then 4, 2. And then we graph all of those points here. And what you see is that you get the sideways parabola. Right? Whew. Here is the same question. Function. And the answer is hell no. Why? Fails vertical line test. You see? You cut with a vertical line and it fails because the vertical line cuts the 2. That means the uniqueness is ruined. Single x produces 2 different y's. Right? Do we see how x equals 4 produces -2 on a y and the +2 on a y? That's what ruins uniqueness. Right? So uniqueness is ruined because of the way the shape the graph is. So this is what I mean. Is the red line an inverse? Yes, it is, right? But is it an inverse function? No, it's not. Okay? So we have to understand that inverse and inverse function are not the same creature. Every function you draw, you can draw an inverse by simply picking points from your function and flipping the coordinates. That's it. you will always have an inverse. Not all of those inverses are functions. In this case, it's not a function, right? The previous case, it was a function. This is going to be extremely important for your pre-calc 2 when talk about trig. You get that sine, that's infinite wave, like this, going forever, right? Once you flip that wave, it's going to be a wave that goes up. You draw a vertical line through that, it cuts infinitely many times, right? Does it have an inverse? Yes. Is this a function? No. And those are the things that you have to be careful about. So now we learned that we can calculate inverse function algebraically by swapping x and y and doing the algebra. And we also see geometrically, graphically, that in some cases when you have inverse function, your output graph, the inverse graph, which is the red one, right, could or could not be a function depending on what you have. Now, to spot that there is no inverse function, we use horizontal line test on the black function, on the original function. So, here in blood, use horizontal line test on the f of x graph. In our case, those are all the black graphs. Use horizontal line test on the f of x graph to check if the inverse is a function. So now I can just immediately go into f of x equals absolute x, right? And I can ask you to use horizontal line test to tell me if the inverse is a function. So use horizontal line test to check if inverse is a function. So what is your verdict? Well, you need to know what the absolute value graph is. Did you memorize that? Because, right, it's a V shape. Very good. So you are already responsible to know this because we learned this in 1.3, then we learned it in 1.6. That the basic shape of this one is that. Good. Now, your horizontal line test is the inverse a function? No. No. Right? So, let's do it this way. HLT failed. Right? Horizontal line test failed. That means inverse is not a function. Inverse is not a function. Let's check another problem. You can go and do this all night. F of x equals square root of x. Use Do we remember what the square root graph is? Of course. What is it? Like a hook. Good. Does this pass HLT? Yes. You can draw a couple of HLTs. Pass. HLT. Pass. Inverse is a function. Now, before I go and talk about something else, let's first see algebraic test to see if two functions are inverses of each other. Now, you're going to have a ton of homework assigned with this question, so knowing the concept obviously will greatly help with those problems. So, test if two functions are inverses of each other. Inverses of each other. Where do you start? Well, first you have to learn the test. And the test says this. If f composed, well, let's do it this way. If f composed with the inverse, which is f of inverse, is equal to x, and inverse composed with f is equal to x, then f and f inverse are inverse of each other. What are you learning? You are learning the theorem over here, which tells you how to check. So let's see our good old f of x is equal to x plus 3, and our inverse, which we said we know, is x minus 3. F composed with the inverse, which is f and plug in the inverse inside, is you take f and you plug in the inverse into x. So, do we all agree that this is my f, x plus 3? Do we all see x plus 3 over here? X plus 3. But instead of x, I put the inverse. And now, when I remove parentheses, I get x. You can do it the other way. You have the inverse to be the boss, and you plug f of x inside. So if inverse is the boss, then you have x minus 3. You plug in x plus 3, which is original f, and what you get is x plus 3 minus 3, you get x again. One more example of this, which is f of x is equal to x squared, and let's say g of x is equal to square root of x. We already know this is true, right? Because 3 squared is 9, square root of 9 is 3, 4 squared is 16, square root of 16 is 4. We see that the square root is going to undo, right, these guys? Okay, let's check. F composed with g is f plug g inside. F is something squared. That something is g, so plug that there. And you get x, because square root cancels a square, right? Nice. G composed with f is, and now we have g, plug f inside. That's going to be g, which is square root of x, but instead of x I have to put x squared because that's what f is. Again, square root and square cancel, and I get x. There's a little bit of a problem there. Remember when I drew these functions earlier, that we said that the other one is not a function? Do we remember that? Yeah. So what's the issue now? Function, not a function. Can I save this situation? And the answer is yes. We use in the last 50 seconds something that is called restricted domain to cut the piece of a function we don't want and create it so it has inverse function. It's called restrictive domain. So what I'm going to do is I'm going to take my good old x squared. I just need to draw 2 pictures and we're done. I'm going to take my good old x squared and I'm going to throw this piece in the garbage and leave the domain 0 to infinity, including 0. Now, what is that going to do when I draw this sideways? When I draw this sideways, since I don't have the branch on the left anymore, it is only going to draw the upper branch, and that is your square root function. And now the inverse is a function. So what did we do? We cut it in half and we threw away the piece that was creating our function to fail horizontal line test, right? Because once I kill this red part that I scratched off, now if you draw those horizontal lines, they will cut through this only once, right? Which means that our inverse will be a function. And we have it. I don't have a closing, so I'm just going to shut off the stream.